What are mathematical models? Are they just equations? Well, they are the use of variables which represent quantities like speed or area and operations to create a representation of what's happening in the real world. Mathematical models are also very handy in this situation of COVID 19 as they help us model disease spread. Since the first case, the number of infected people has just been getting higher, and the number of susceptible people, that is, people free of COVID 19, has been getting lower. So we can say that the quantities of susceptible people and infected people are inversely related. That means if there is one less susceptible person, there is one more infected person, and vice versa. Thus, the rates of change for both of these quantities are the same. The only difference is that one increases while the other decreases. You must have learned if a rate increases, the slope is positive. If it decreases, it's negative. So if the rate of change of infected people is x, then the rate of change of susceptible people will be minus x. This brings us to the first equation, rate of change of susceptible people. Beta here is the infection rate, that is number of people infected per unit time. S and I give us the initial values of susceptible and infected individuals. Note that the negative sign tells us about the decreasing rate of this quantity. In the second equation, we find out the rate of removed people. Gamma here is the death rate. What we are really looking for is the fraction of people who are removed after getting infected. The third and final equation is the rate of infected people. You can find the total number of people infected by multiplying beta, S and I. However, you need to subtract the fraction of people who are later removed, and that is why we subtract gamma I. This set of equations is known as the SIR model and is widely used to model pandemics. Speaking of models, in certain cases, some tools may be more useful to us than others, and that's where the clique graph comes in handy. Its uneven distribution of nodes makes it the perfect tool to model pandemics. We could also use the coordinate plane, but people aren't uniformly distributed, we're uneven, and that is why the clique graph brings us one step closer to reality. Apart from graphs and variables like beta and gamma, there are other things that model disease spread. Such as how does it spread? Is it waterborne, airborne, or does it spread by human contact? Is it a virus, a bacteria, fungi, or some sort of parasite? How many organisms can it spread to? What are the weather conditions it thrives in? Can it mutate into something much worse? And more importantly, how are people behaving? Are they social distancing? In order to tell you how social distancing is important, let's take these three people. Let's say they infect two each. Of course, this is a very ideal scenario, but we see that the number exponentially increases from 3 to 48. However, if just one stayed home, he or she could prevent so many other people from being infected. And that is the impact just one person has. That is the impact you have.